Webb reveals an exoplanet atmosphere as never seen before. The NASA ESA CSA James Webb Space Telescope just scored another first, a molecular and chemical portrait of a distant world's skies, while Webb and other space telescopes, including the NASA ESA Hubble Space Telescope, have previously revealed isolated ingredients of this heated planet's atmosphere. The new readings provide a full menu of atoms, molecules, and even signs of active chemistry in clouds. The latest data also give a hint of how these clouds might look up close, broken up rather than as a single, uniform blanket over the planet. Welcome back to my channel. Before we proceed, kindly subscribe to our channel and hit the bell icon to stay updated when we release new videos. Without further delay, let's dive in. The telescope's array of highly sensitive instruments was trained on the atmosphere of WASP 39 bits, a hot Saturn, a planet about as massive as Saturn, but in an orbit tighter than Mercury, orbiting a star some 700 light-years away. This Saturn-sized exoplanet was one of the first examined by the NASA ESA CSA James Webb Space Telescope when it began regular science operations. The results have excited the exoplanet science community. Webb's exquisitely sensitive instruments have provided a profile of WASP 39 bits' atmospheric constituents and identified a plethora of contents, including water, sulfur dioxide, carbon monoxide, sodium, and potassium. The findings bode well for the capability of Webb's instruments to conduct the broad range of investigations of exoplanets, planets around other stars, hoped for by the science community. That includes probing the atmospheres of smaller rocky planets like those in the TRAPPIST-1 system. We observed the exoplanet with several instruments that together cover a broad swath of the infrared spectrum and a panoply of chemical fingerprints inaccessible until JDLST, said Natalie Bathalha, an astronomer at the University of California, Santa Cruz, who contributed to and helped coordinate the new research. Data like these are a game-changer. The suite of discoveries is detailed in a set of 5 new scientific papers, 3 of which are in press and 2 of which are under review. Among the unprecedented revelations is the first detection in an exoplanet atmosphere of sulfur dioxide, a molecule produced from chemical reactions triggered by high-energy light from the planet's parent star. On Earth, the protective ozone layer in the upper atmosphere is created in a similar way. This is the first time we have seen concrete evidence of photochemistry, chemical reactions initiated by energetic stellar light, on exoplanets, said Shagmin Sai, a researcher at the University of Oxford in the United Kingdom and lead author of the paper explaining the origin of sulfur dioxide in WASP 39 bits' atmosphere. I see this as a really promising outlook for advancing our understanding of exoplanet atmospheres with this mission. This led to another first. Scientists applying computer models of photochemistry to data that require such physics to be fully explained. The resulting improvements in modeling will help build the technological know-how needed to interpret potential signs of habitability in the future. Planets are sculpted and transformed by orbiting within the radiation bath of the host star, Bathalha said. On Earth, those transformations allow life to thrive. The planet's proximity to its host star, 8 times closer than Mercury is to our Sun, also makes it a laboratory for studying the effects of radiation from host stars on exoplanets. Better knowledge of the star-planet connection should bring a deeper understanding of how these processes affect the diversity of planets observed in the galaxy. Other atmospheric constituents detected by the Webb telescope include sodium, potassium, and water vapor, confirming previous space and ground-based telescope observations, as well as finding additional fingerprints of water at these longer wavelengths that haven't been seen before. Webb also saw carbon dioxide at higher resolution, providing twice as much data as reported from its previous observations. Meanwhile, carbon monoxide was detected, but obvious signatures of both methane and hydrogen sulfide were absent from the Webb data. If present, these molecules occur at very low levels. To capture this broad spectrum of WASP 39 bits' atmosphere, an international team numbering in the hundreds independently analyzed data from 4 of the Webb telescope's finely calibrated instrument modes. We had predicted what the telescope would show us, but it was more precise, more diverse, and more beautiful than I think I actually believed it would be, said Hannah Wakeford, an astrophysicist at the University of Bristol in the United Kingdom, who investigates exoplanet atmospheres. Having such a complete roster of chemical ingredients in an exoplanet atmosphere also gives scientists a glimpse of the abundance of different elements in relation to each other, such as the carbon-to-oxygen or potassium-to-oxygen ratios. That in turn provides insight into how this planet, and perhaps others, formed out of the disk of gas and dust surrounding the parent star in its younger years. WESP 39 bits' chemical inventory suggests a history of smash-ups and mergers of smaller bodies called planetesimals to create an eventual goliath of a planet. The abundance of sulfur relative to hydrogen indicated that the planet presumably experienced significant accretion of planetesimals that can deliver these ingredients to the atmosphere, said Kazumasa Ono, a UC Santa Cruz exoplanet researcher who worked on Webb data. The data also indicates that the oxygen is a lot more abundant than the carbon in the atmosphere. This potentially indicates that WASP 39 bits originally formed far away from the central star. By precisely revealing the details of an exoplanet atmosphere, the Webb telescope's instruments performed well beyond scientists' expectations and promise a new phase of exploration of the broad variety of exoplanets in the galaxy. We are going to be able to see the big picture of exoplanet atmospheres, said Laura Flagg, a researcher at Cornell University and a member of the international team. It is incredibly exciting to know that everything is going to be rewritten. That is one of the best parts of being a scientist. The clarity of the signals from a number of different molecules in the data is remarkable, says Mercedes Lopez Morales, an astronomer at the Center for Astrophysics, Harvard and Smithsonian, and one of the scientists who contributed to the new results. The latest data also give a hint of how these clouds and exoplanets might look up close, broken up rather than a single uniform blanket over the planet. As an early career researcher in the field of exoplanet atmospheres, it's so exciting to be a part of a detection like this, Adams says. The process of analyzing this data felt magical. We saw hints of this feature in early data, but this higher precision instrument revealed the signature of SO2 clearly and helped us solve the puzzle. At an estimated temperature of 1,600 degrees Fahrenheit and an atmosphere made mostly of hydrogen, WESP 39 bits is not believed to be habitable. The exoplanet has been compared to both Saturn and Jupiter, with a mass similar to Saturn, but an overall size as big as Jupiter. But the new work points the way to finding evidence of potential life on a habitable planet. The planet's proximity to its host star, 8 times closer than Mercury is to our Sun, also makes it a laboratory for studying the effects of radiation from host stars on exoplanets. Better knowledge of the star-planet connection should bring a deeper understanding of how these processes create the diversity of planets observed in the galaxy. Other atmospheric constituents detected by JWST include sodium, potassium, and water vapor, confirming previous space and ground-based telescope observations, as well as finding additional water features at longer wavelengths that haven't been seen before. JWST also saw carbon dioxide at higher resolution, providing twice as much data as reported from its previous observations. Meanwhile, carbon monoxide was detected, but obvious signatures of both methane and hydrogen sulfide were absent from the data. If present, these molecules occur at very low levels, a significant finding for scientists making inventories of exoplanet chemistry in order to better understand the formation and development of these distant worlds. Capturing such a broad spectrum of WASP 39 bits' atmosphere was a scientific tour de force, as an international team numbering in the hundreds independently analyzed data from 4 of JWST's finely calibrated instrument modes. They then made detailed intercomparisons of their findings, yielding yet more scientifically nuanced results. That's all I have for you guys for today. If you liked watching this video, please make sure to click the like button, subscribe to our channel, and click the bell icon so that you may be notified when we upload a new video. Thanks for watching.